Hello student, welcome back. We are going to start today's session. It is Lecture 3, Module 1. Microcontroller and Embedded System. Shongita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. In the previous content, we have studied commercial microcontroller devices and families. Today's session, the content is Microcontroller 8051 architecture, block diagram of the architecture of 8051. The 8051 microcontroller is one of the basic type of microcontroller designed by Intel in 1980s. This microcontroller was based on Harvard architecture and developed primarily for use in embedded system technology. Normally, this microcontroller was developed using NMOS technology, which requires more power to operate. Therefore, Intel redesigned microcontroller 8051 using CMOS technology, and their updated versions came with a letter C in their name. For instance, an 80C51. It is an 8-bit microcontroller. These latest microcontrollers require less power to operate as compared to their previous versions. The 8051 microcontroller has two buses and two memory spaces of 64K into 8 size for program and data units. It has an 8-bit processing unit and 8-bit accumulator unit. The 8051 microcontroller architecture showing below. So this is the architecture of 8051 microcontroller. This is the bus. This is 4K ROM, 128 bytes RAM, timer 1, timer 0. This is the counter inputs. Serial control. It is transmitter data bus, it is receiving data bus. 4 I/O ports, PO0, PO1, PO2, PO3. PO0, PO2 address or data. Bus control. This is the oscillator circuitry. This is the crystal oscillator. This is the CPU, central processing unit. This is interrupt unit, interrupt control. This is external interrupt. So this is the basic block diagram of 8051 microcontroller. So the central processing unit, CPU. As we know that the CPU is the brain of any processing device of the microcontroller. It monitors and controls all operations that are performed on the microcontroller units. The user has no control over the work of the CPU directly. It reads programs written in ROM memory and executes them and do the expected task of that application. Interrupts. As its name suggests, interrupt is a subroutine call that interrupts of the microcontroller's main operation or work and causes it to execute any other program, which is more important at the time of operation. The feature of the interrupt is very useful as it helps in case of emergency operations, and interrupts give us a mechanism to put on hold the ongoing operations. They execute a subroutine and then again resumes to another type of operations. The microcontroller 8051 can be configured in such a way that It temporarily terminates or pause the main program at the occurrence of interrupts. When a subroutine is completed, then the execution of main program starts. Generally, 5 interrupt sources are there in 8051 microcontroller. There are 5 vector interrupts that is shown below. INTO, TFO, INT1, TF1, R1, T1. Out of these, INTO and INT1 are external interrupts that could negative edge triggered or low level triggered. When all these input interrupts are activated, set the corresponding flags except for serial interrupt. The interrupt flags are cleared when the processor branches to the interrupt service routine ISR. The external interrupt flags are cleared when the processor branches to the interrupt service routine, provides the interrupt is a negative edge triggered, whereas the timer and serial port interrupts, two of them are external interrupts. Two of them are timer interrupts and one serial port interrupt terminal in general. Memory. Microcontroller requires a program which is a collection of instructions. This program tells microcontroller to do specific tasks. This program requires a memory on which this can be saved and read by microcontroller to perform specific operation of a particular task. The memory which is used to store the program of microcontroller is known as code program. And program memory of applications. It is known as ROM memory of microcontroller, also requires memory to store data or operands temporarily of the microcontroller. The data memory of the 8051 is used to store data temporarily for operation is known as RAM memory. 8051 microcontroller has 4K of code memory and program memory. That has 4 KB ROM and also 128 bytes of data memory of RAM. Bus. Basically, bus is a collection of wires which work as a communication channel or medium for transfer of data. These buses consists of 8, 16 or more wires of microcontroller. Thus, these can carry 8 bits, 16 bits simultaneously. Two types of buses that are shown below: address bus and data bus. Address bus. Microcontroller 8051 has a 16-bit address bus for transferring the data. It is used to address memory location and to transfer the address from CPU to memory of the microcontroller. It has 4 addressing modes that are immediate addressing mode, bank or register addressing mode, direct addressing mode, and register indirect addressing mode. Now the interrupts. The most powerful attribute of the 8051 microcontroller is the concept of interrupts. This interrupts is a mechanism to temporarily suspend the ongoing program, pass the control to a subroutine, execute the subroutine, resume the ongoing main program. Interrupt can be various types of, such as software and hardware interrupts, non-maskable and maskable interrupt, etc. Now, the 8051 microcontroller incorporates 5 interrupts. This is INTO, external hardware interrupt, TFO, timer O, overflow interrupt, INT1, external hardware interrupt, TF1, timer 1 or overflow interrupt. R1 or T1, serial communication interrupt. Input and output ports. The 8051 microcontroller needs to be connected to the peripheral devices in order to control their operation. The I/O ports are responsible for the connection of the microcontroller to its peripheral devices. There are total 4 8-bit input output ports present in this microcontroller. Additionally, these are some important features of 8051 microcontroller given as follows. Number 1, two 16-bit timers and counters, 2 a data pointer and a counter, program counter of 16-bit each, 128 user-defined flags, 4 register banks, 31 general-purpose registers which are of 18-bit each. So this is the pin diagram of 8051 microcontroller. There are total of 40 pin and the structure is looking like this. This is the structure or how it will be looking. And pin configuration is 1, 2, 3, 4 up to 20, and from here it is 21 to 40. The 8051 microcontroller is a 40-pin plastic dual in package PDIP. The function of the pins of the microcontroller are as follows. Port of 8051 microcontroller. Port 0. The port 0 or P0 is the general purpose I/O port. Consequently, it consists of 8 pins starting from pin 32 to pin 39. However, this port can also be utilized as a multiplex address and data bus from 80 to 87. Port 1. Port 1 or P1 is also an 8-bit port starting from pin 1 to pin 8. Although similar to the PO, the P1 is also general purpose I/O port. However, unlike the other 3 ports, P1 does not serve any dual purpose. Hence, the sole purpose of P1 is for interfacing. Port 2. The pins from 21 to 28 belong to the port 2 or P2. Now, when there is no presence of an external memory, the P2 acts as a general purpose I/O port. However, in the presence of external memory, P2 acts as an address bus starting from A8 to A15. Port 3. Though the port 3 or P3 usually acts as a normal I/O port, it can provide some other function as well. The pin numbers are from 10 to 17. The other functions are showing below. Pin 10, it is receiver data. Pin 11, transmitter data. Pin 12, INTO complement. Pin 13, INT1. Pin 14, TO. Pin 15, T1. Pin 16, read for writing. Pin 17, read complement. Means when it is 0, then it will be read, and when it is 1, it is not activated. Additionally, there are other pins as follows. Pin 20 ground, pin 40 VCC power supply, pin 9 RST reset, pin 18 XTAL1, this is crystal oscillator, pin 19 XTAL2, it is also oscillator, pin 29 P send program store enable, pin 30 address latch enable, pin 31 external access. Hence, this was the pin diagram of 8051 microcontroller. Finally, moving on to the application side of 8051 microcontroller. The application of 8051 microcontroller is the rapid growth of technology. We can use the microcontroller in a wide way. Thus, from our daily lives to industrial application, it is no doubt that microcontroller is omnipresent. So, here is a list of some of the major applications incorporating the 8051 microcontroller. Number 1, in robotics. Robotics is a technology that is one of the exponential increasing. This industry relies heavily on the microcontroller for their development. Hence, the 8051 is used widely in the robotics industry. IoT, Internet of Things technology, is a booming industry since 2018. Furthermore, this new technology has been creeping into almost all the industries in the world. Thus, the use of microcontroller has increased as this is a vital component for any smart devices. Temperature and light sensing devices, process control devices. Now, we can recapitulate again what is microcontroller. A microcontroller is a small, low-cost and self-contained computer on chip that can be used as an embedded system. A few microcontrollers may utilize 4-bit expressions and work at a clock rate frequency which usually include 8-bit or 16-bit microprocessor, a little measure of RAM, programmable ROM and flash memory, parallel and serial I/O, timer and signal generators, analog to digital and digital to analog conversion. Microcontrollers usually must have low power requirements since many devices they control are battery operated. Microcontrollers are used in many consumer electronics, car engines, computer peripherals, and test or measurement equipment. And these are well suited for long-lasting battery applications. The dominant part of microcontroller being used nowadays are implanted in other apparatus also. How are microcontrollers classified? The microcontrollers are characterized regarding bus width, instruction set, and memory structure. For the same family, there may be different forms with different sources. This article is going to be describe some of the basic types of the microcontroller that newer users may not know about. The types of microcontroller is shown figure. They are characterized by their bit, memory architecture, memory devices, instruction set. So microcontroller may be classified 8051, AVR and PIC. The bit in microcontroller are 8 bits, 16-bit, 32-bit microcontroller. In 8-bit microcontroller, the point when the internal bus is 8-bit, then the ALU is performed, arithmetic logic unit, it performs the arithmetic and logic operation in 8-bit. The example of 8-bit microcontrollers are Intel 8051, PIC 1X and Motorola MC68HC11 families. The 16-bit microcontroller performs greater precision and performance as compared to 8-bit. For example, a 8-bit microcontroller can only use 8 bits, resulting in a final range of 0 into 00 to 0xFF. That is to 0 to 255 for every cycle. In contrast, 16-bit microcontrollers with its 16-bit data width has a range of 0x000 to 0xFFFF. That is to 0 to 65535 for every cycle memory location. A longer time, most extreme worth can likely prove to be useful in certain applications and circuits. It can automatically operate on two 16-bit numbers. Therefore, in earlier for 8-bit, it is operated on 8-bit, whereas in 16-bit, the range is more, so it can operate it on 16-bit. Some examples of 16-bit microcontrollers are 16-bit MCUs are executed on 8051XA, PIC2X, Intel 8096, Motorola MC68HC12 families. The 32-bit microcontroller uses the 32-bit instructions to perform the arithmetic and logic operation. These are used in automatically controlled devices including implantable medical devices, engine control system, office machines, appliances and other embedded systems. Some examples are Intel Atmel 251 family, PIC3X families. Classification according to memory devices. The memory devices are divided into two types. They are embedded memory microcontroller, external memory microcontroller. Embedded memory microcontroller. When an embedded system has a microcontroller unit that has all the functional blocks available on a chip is called an embedded microcontroller. For example, 8051 having program and data memory, I/O ports, serial communication counters, and timers and interrupts on the chip. It is an embedded microcontroller. External memory microcontroller. When an embedded system has a microcontroller unit that has all the functional blocks available on a chip is called an external memory microcontroller. For example, 8031 has no program memory on the chip. It is an external memory microcontroller. Classification according to instruction set. CISC. CISC is a complex instruction set computer. It allows the programmer to use the one instruction in place of many simple instructions. RISC. The RISC stands for Reduced Instruction Set Computer. This type of instruction sets reduce the design of microprocessor for industry standards. It allows each instruction to operate on any register or use any addressing mode and simultaneously access of program and data. So this is an example how the CISC and RISC standards are used. For instruction, it is shown move AX 4, move BX, 2, add BX, AX, whereas the same program can be written in RISC system as move AX, 0, move BX, 4, move CX, 2, begin add AX, BX, loop begin. So that indicates RISC, it is long form, CISC is a short form. From above example, RISC system shorten execution time by reducing the clock cycles per instruction, and CISC system shorten execution time by reducing the number of instruction per program. The RISC gives a better execution than CISC. Classification according to memory architecture. Memory architecture of microcontroller are two types. They are namely Harvard Memory Architecture Microcontroller, Princeton Memory Architecture Microcontroller. Harvard Memory Microcontroller Architecture, the point when a microcontroller unit has a dissimilar memory addresses space for the program and data memory. The microcontroller has Harvard Memory Architecture in the processor. Whereas Princeton Memory Architecture Microcontroller, the point when a microcontroller has a common memory address for the program memory and data memory, the microcontroller has Princeton Memory Architecture in the processor. So how it looks, it is shown over there. This is the atomic 32. So how working the microcontroller can be divided into three steps. Programming the microcontroller, burning it in the IC, then connect to the external network. Microcontroller programming is very much similar to the programming of language C. So these are some of the application. Line follower robot. Already in the earlier class we have shown this. This is one application where microcontroller can be used in medical appliances, in power system. These are the references. Thank you. We are ending the session.